Have you ever wondered how it all began? How this vast, seemingly infinite universe sprang into existence? From the swirling galaxies to the smallest particles, everything has a beginning. And for our universe, it began with a big, explosive event known as the Big Bang. The Big Bang wasn't an explosion in the traditional sense. It wasn't something that happened at a particular spot in space. Instead, it was a moment approximately 13.8 billion years ago when the universe as we know it began to expand from an incredibly hot, dense state into what we see today. This wasn't a slow, ponderous growth either. In the initial fractions of a second, the universe expanded faster than the speed of light, a period known as the inflationary epoch. This rapid expansion smoothed out the universe, leading to its uniformity in all directions. Following the inflationary epoch, the universe entered what's known as the radiation-dominated era. Here, the universe was a hot, dense sea of particles, primarily photons, neutrinos, electrons, and their antiparticles. These particles were constantly colliding, creating a state of matter known as a plasma. As the universe continued to expand and cool, it eventually reached a point where protons and neutrons could combine to form the first atomic nuclei, a process known as nucleosynthesis. This marked the end of the radiation-dominated era and the beginning of the matter-dominated era. The universe was now cool enough for atoms to form. Hydrogen and helium, the simplest elements, formed in abundance. The universe was no longer a plasma, but a neutral gas. This marked the end of what's known as the cosmic dark ages. With the formation of atoms, the universe became transparent to light for the first time. In this matter-dominated era, the seeds of galaxies and stars began to form. Gravity pulled matter together, creating dense regions that would eventually ignite to form the first stars and galaxies. This period, known as the Epoch of Reionization, marked the birth of the universe as we know it. Fast forward to today, and we find ourselves in the late stages of the matter-dominated era. The universe continues to expand, but now there's a new player in the game, dark energy. Represented by the Greek letter lambda in the LambdaCDM model, dark energy is causing the universe's expansion to accelerate. So, here we are, in a universe that started with a Big Bang, expanded faster than the speed of light, was filled with a hot, dense plasma, saw the formation of the first atoms, the first stars and galaxies, and is now dominated by mysterious dark energy. This is the LambdaCDM model of the universe, a model that explains the evolution of the universe from its fiery birth to the present day. In summary, the universe began with the Big Bang, followed by rapid expansion during the inflationary epoch. It then entered the radiation-dominated era, where it was a hot, dense plasma. As it cooled, it transitioned into the matter-dominated era, with the formation of the first atoms marking the end of the cosmic dark ages. The birth of the first stars and galaxies marked the epoch of reionization. Today, we find ourselves in the late stages of the matter-dominated era, in a universe whose expansion is accelerating due to the mysterious force of dark energy. This is the story of our universe, as told by the LambdaCDM model.